Mrs. John with lesson 2 for year 12 physics, and this lesson is on electric potential energy. So charge gains electric potential energy when it is forced to move against the field, and charge loses electric potential energy and it gains kinetic energy when it moves in the direction of the electric field. So what does this all mean? So if you look at this diagram, there are two oppositely charged plates and there is an isolated positive charge here. If left on its own free will, what would it like to do? It would like to go towards or accelerate to the negative plate, because unlike charges attract. But in order to keep it to get it to move towards the positive plate, you actually have to force it to do so, to move that distance. So when you're forcing a charge to do something it doesn't really like to do, that's when it gains electric potential energy. Okay, and the energy gained is equal to work done, and so work done is force times distance. That's equal to the electric potential energy gained. So we know that F is equal to EQ, that we've just learned in the last topic over here, this one here. And so we have the electric potential energy gained is EQD. Note there are two E's over here, so this capital E by itself, sometimes it might have that or that, and that is your electric field strength, whereas the delta EP is the change in electric potential energy. So if the charge moves in the direction of the electric field, it will lose electric potential energy and it will gain kinetic energy, and as it approaches the opposite charge it's going to accelerate towards the opposite plate, because the size of the force of attraction will increase, and so this kinetic energy is given by EK is half mv squared. Now I have some problems on the electric field which you are most welcome to try out using the formulae, and then check my answers over here. I may not have written the whole question, but from my working you can kind of make out which were the part questions over here, and then I think there's one more